If you have wondered why I left this question for the last episode, it's because it turned out to be much more complicated than I originally thought. Hello, and welcome back to the channel. If you're absolutely new to the channel, you should really watch the nutshell video first. It's just 90 seconds and will really help you to fully understand the content of this and other episodes. So far, we mostly talked about lifting and transporting the stones. Now we have to talk about laying them. We can distinguish several levels of difficulty here, depending on how many sides of already laid stones the new stone has to connect to. The easiest situation would of course be when there are no other stones around that we have to connect to horizontally, but we only have that luxury for the first casing stone of a new layer. Let's call that type 0. Still very easy when we just have to shove the stone next to an already laid stone. That's what we have for all the other casing stones. Let's call that type 1. It's still rather easy to shove a stone into a corner. That's the most common situation for all the inner stones. Call that type 2. Type 3 becomes a little tricky. That's when we have to shove the new stone into a gap. The stones of a layer are selected to have the same height, pretty precisely. They will also have the same width. If they don't, that would leave us with some nasty little protrusions that would make continuing our normal or usual laying pattern much more difficult. So we don't want that. But for the length of a stone, we have a lot more tolerance in our usual laying pattern. So they will come in varying lengths. So before we can shove the stone very precisely into that gap without jamming it, we have to first measure that gap and order a stone of exactly that length from the staging area. We could do that, but it will make things more complicated and more time consuming, so we will want to avoid that as good as we can. So, if we have our lines side by side, each responsible for the same width of a strip where they lay their stones, it's pretty obvious that line B cannot start with their first row of stones before line A hasn't finished their first line. Same with line C, waiting for B, and so on. That will work as long as all the lines operate with exactly the same speed all the time. But there are 4 different reasons why that will not be the case. The workers were organized in teams and they were competing for some incentive. So each line would like to be faster than their neighbors. And as in every competition, the team lagging behind will take a close look how the faster team does it and try to imitate that. If that doesn't help, maybe some kind of instructor would show up telling them what they are doing wrong. And if that doesn't help, maybe assign an additional worker to the team. And if even that doesn't help, in order to compensate for this difference in speed, the faster team could occasionally donate a stone to the slower team. So if one team lags behind significantly, the following situation would occur. Line B could not lay its current stone without producing a type 3 gap. So instead of waiting for line A to finish their current row, they could just donate a stone to line A. And some sort of referee would keep track of all those donations to keep the competition fair. On the construction side, many things will happen all the time that will interrupt the normal workflow. Tools have a tendency to break down, workers can get sick, you name it. So let's assume the main rope of line A has suffered some wear and tear and they decide to replace it. That process will take about an hour, but in an hour, a line can deliver one or more rows of stone. But instead of having all the lines wait for line A to resume work, we will do the following. Line B will donate almost all their stones to line A. Those stones will have to be moved a little bit more sideways, but they will have the help of the laying team of line A, which would be idling anyway, because line A doesn't deliver stones for that. Likewise, line C would donate many of their stones to line B. Line D would deliver half of their stones to line C, and so on. That way, we can distribute the delay across several lines, making it less bad. But we won't get away without some lines waiting for some time. While such events will happen randomly, another reason for different speeds will recur on a regular basis. If we have finished a layer and get on to the next layer, say 1 meter higher, the size of the top of the pyramid will also shrink by roughly the same amount. So all lines will become 2 meters shorter, and in addition to that, the both outmost lines, say the eastern and the western line, will lose 1 meter in width. So they have to deliver less stones now. But after a few more layers in height, the shrinking will consume the space where the rails of line A are, and so they will have to stop working, and line B has to jump in and take over that part of the strip, needing the help of line C needing the help of line D. The fourth reason for different speeds has its origins in the center of the pyramid. The center lines usually deliver regular internal stones, but when they get to the spaces where the burial chambers or the gallery is, then the big stones come in. And as I pointed out in a previous episode, they will need the help of the adjacent lines, interrupting their work. And as we don't even know the exact dimensions of those big stones, not to mention the methods with which they laid them, it's impossible to tell how they would organize. They can, of course, use the donation methods I just described, and as a last resort, they could give the workers, some workers of some lines, an extended lunch break or even a day off. So that's it for today. This is probably the last episode of this little series, unless I made a big mistake or forgot something. As always, please like, share and subscribe and spread the news. And most of all, thank you very much for watching.